Let's see. Let me double check to see if I'm live on Facebook. It should show me. Let me refresh this page. And I'm gonna try on YouTube. Hey, let me know if you find if I'm live on YouTube /the Jax Tutor. If you can see me live on YouTube, let me know. Unit circle. Okay, we'll go about a little bit of that. If we have some time, we'll go on over unit circle. Unit circle. Circle. And honestly, I don't remember the rest. All right, so who can see me live on YouTube? If you're able to go see me live on YouTube, it's the channel's name on YouTube is the Jax Tutor. I'm gonna tap it on both chats so you can see it. So it's youtube.com/the Jax Tutor. Or you can just look for the Jax Tutor on YouTube. That's the channel's name on YouTube. Let's see. TikTok, y'all should probably have it already. Let's see. I'm trying to find a way to comment here. No, comment. There you go. That's the channel's name on YouTube. So let me know if you can see me live on YouTube. I'm gonna double check to see if I'm live on Facebook as well. Yes, it is live on Facebook. Let's see if you guys can see me. Let me know if you can see me live on YouTube. Let's see. Yeah, it says live now. Yeah, you guys should be able to see me on YouTube. Yeah. Yeah, it says live now. Okay. If you're having any troubles too, you know what? Let me hook up my mic though. I'm out here playing. Let me hook up my mic 1 second. I should bring a little bit better sound. Last time I forgot, and today I almost forgot too. Can you hear me? Can you guys hear me? I can't see you live on YouTube. Go on youtube.com/the Jax Tutor. You will see. You will see a red button that says live now. I just check it, and I'm looking at it now. It says live, and there are people watching on it. So I'm not sure if you're having trouble. There are people currently watching YouTube, so you should be able to see it. Let me know if you're still having trouble, so I can see what I can do for you. If you guys are able to hear me, let me know as well. If you can hear me on YouTube, let me know. My freshman year. IB geometry my freshman year. Is geometry hard? It depends. It depends on what class you took before you took geometry, and also your like how much you like math. So being hard is it's not it's relative to the person. So for you it might be hard. For me it might be really really easy, or for somebody else it might be really hard. For me, it might be really hard. So it depends on the person. So, and it also depends on what classes you've taken before that. If you're coming in, never take any math classes, of course it's going to be, it's going to be new and probably hard for you. But if you have taken a lot of math classes before you excel at them, chances are it might be a little bit easier for you. So it's kind of like a hard question to answer. It really depends on the person. Man, I don't know what's going on with this sliding all the way down. All right, cool. So let's start. All right, let me see, double check. You guys are able to see me. Ooh, this delay is terrible. You guys should be able to see me on YouTube and Facebook. Okay, so all right, you guys wanted me to talk about exponents. So those are, so it's usually you'll find those in algebra and algebra 1, geometry, sometimes maybe pre-algebra. They'll give you stuff about exponents and they ask you to solve it. They ask you to to multiply them, to add them. And there's a little bit of rules and tricks that you have to remember. So that way that you're able to do it easily when you see them and also not mess up too. So it's not about knowing how to solve every problem in the book. It's knowing how to, know the tricks that whenever you present with a case, you know exactly what to do. So on page 2, let's start in about exponents. So let's talk about exponents. All right, so this stylus is really good. I lost 4 of them. I found them. All right, cool. So let's think about what we saying. So it's like a number to a certain power. So if they have 2 to the third, what that really means is 2 multiply 3 times, multiply by itself 3 times. So it's 2 times another 2 times another 2. So that's 2 to the third. 2 to the fourth, the same way, by the same token, 2 to the fourth is, if you're having trouble hearing me on YouTube too, let me know. 2 to the fourth is 2 times another 2 times another 2 times another 2, 4 times, right? So to the fifth, the same thing, 5 times to the sixth, 6 times. Normally kids understand that. You understand the fact that they tell you, so whatever the base is, tell you what number you're dealing with. The exponent tells you how many times you got to multiply this number by itself. And when you're dealing with positive exponents, it's easy to see that 2, I have to multiply it by itself 3 times. And if I have 5 to the third power, what that would mean. So the base tells me what number I'm dealing with. So that means I'm dealing with 5. The exponent tells me how many times I'm multiplying this 5 by itself. So I mean by multiplying it by itself 3 times. So here, 5 is 5. 5 to the third is 5 times 5 times another 5. So now, this is done. This is, you kind of get this. And you guys have any questions? Let me see if you have any question on YouTube. Oh no, I'm not sharing my screen. Okay. I am on mute. I was wondering why there's such a delay. Okay, I wasn't sharing my screen. Where is the screen? Oh, there you go. Jesus Christ. I'm sorry, y'all. I can hear you. Okay, you good. I can hear you. Okay. All right, cool. Thank you. Thank you, Corbin. Ian, what's up? Thank you. All right, cool. So now I'm sharing my screen. I don't know why I thought I was before. But now there you go. Now I'm sharing my screen, and I want it this way. That's what I'm talking about. Okay. So you should be able to see me clearly now and hear me on YouTube. So if you not on YouTube, go on youtube.com/LeJax Tutor, or just go on YouTube, type LeJax Tutor. You will see us live, and you'll see a button that says we're live. And if you're having trouble hearing us too, let us know. So I think this should be good. Let's see. I think I'm sharing it. There we go. So I'm seeing it on YouTube. I'm seeing the screen on YouTube. And I think I should be seeing it on Facebook as well. Yes, there you go. So it's on Facebook and YouTube. So you guys are all seeing the screen now. So now, let's go back. Let's go back to what we were saying. So we're saying that if you have a number, so when we're dealing with the exponent, so we have 2 numbers. So one of them is the base. So 6 to the third power. The 6 is the base. The 3 tells you how many times you got to multiply the 6 by itself. So 6 to the third power is 6 times another 6. A bunch of wires in front of me. 6 times 6 times another 6. And that's 6 to the third power. So now, whatever you go on your calculator, you multiplying them and they'll tell you what it does. Now, what kids normally have problem with, you guys understand how to multiply 6 by itself 3 times. Do you have any questions? Let me see if you guys have any question about that. Let's see. We can see everything now. That's good. Ian, that's Ivan. That's good. Cool. Now, if you have any question about this, let me know. Um, so that's how you do 6 to the 3rd power. Now, what kids normally have problems with is when you get two numbers, you suddenly multiply them or add them. Now, when you're dealing with exponents, if I'm adding, let's first go to adding. If I have 2 to the 3rd power plus 2 to the 4th power, there's no way I can add those without first calculating the first one and then calculating the second one. So now you don't add this two and this two. You don't add this three and this four. Those are two different numbers. Now we go back to the basics. So the way that you would do that, you go back to the basics. You say 2 to the 3rd is 2 times another 2 times another 2. So let's take care of this part. And then plus 2 to the 4th is 2 times another 2 times another 2 times another 2, 4 times. And that take care of this part. So now you have 2 to the 3rd and also 2 to the 4th taken care of. So now how do we find the what that equals to? So the best way to do that is to go on the Google calculator. You can either say 2 to the 3rd, and that gives you 8. You put the 8 right here. And let me not put the 8 right here, plus 2 to the 4th. Of course, that's 8 times another 2, 2 to the 4th. And that's 16. You put the 16 right here. So 8 plus 16. And these are the two numbers that you can add. When you do an addition, when you subtract them, these are, he's going over exponents. Are you on YouTube? Because I'm not sure. If you're not, what's the math problem we're doing? We gotta go on YouTube to see it. Because you cannot share your screen on TikTok, and I don't think you can even do that on Instagram too without doing something weird. So I could show you the screen here, but it would be weird. Just go on YouTube. You'll see exactly what we're doing. Just go on YouTube, and that's where everything is, and everybody else is there. So if you're not able to see the screen, just go on YouTube, and you'll see exactly what we're doing. Now, can we do a Zoom? Not I didn't set it up for this time around. I'm playing around with a few software. I probably eventually I might be able to do that where everybody can go on Zoom. But I'm gonna see. Because that might be the best option. And I don't think they have that. I don't think they have that with the software that I'm using. I'm moving the software called Restream. I don't know exactly if they have it. I know they have Facebook and YouTube and I don't think they have Zoom on there. But I'll find a way. I'll find a way eventually where I can do a Zoom and have you guys all in it in one class and send y'all a link. And that probably would be a best option. Um, we'll see how to do that eventually. You can also try Google Class, I think. Google Classroom. Have you guys ever used it? I think I have the app on my phone and on my computer too. But I don't think I ever use it. Uh, if you guys have a good experience with Google Classroom, what would be better, Zoom or Google Classroom? Let me know. So that way we'll find whichever one we can use. Because the software that I was trying to download on my phone on my computer was not, it just wasn't taking it. It's a software called OBS. That would have been better for me because I would be able to do a bunch of those like Zoom. Um, but I think I should be able to find a walk around. Give me a few days. Give me a few days. Probably not on the one from tomorrow, but give me a few days. I'm gonna find a best option and be able to have you guys on there. Because that will be a lot less screen. Never used Google Classroom, so I think Zoom. Okay, yeah, but it is the screen. The screen that you guys should be seeing is on Instagram, is on YouTube right now, so you should be able to see it. Let's see. All right, cool. So So that's how you would add those. These two numbers, that's the only way to add them. So you say 8 plus 16. So you go, if you don't remember what that is, you say 16, you add another 8 to it. So that's the only way you could add those when you get 24. Now, normally when they give you problem, they usually don't give you when they give you exponent problem, they usually don't give you those. They usually don't give you, add them unless they want to trick you. So what you really will encounter is things like multiplication. So let's say that we had 2 to the 5th power times 2 to the 7th power. Now, so who can tell me what this would equal to? And I'll give you guys about 10 seconds. I know there's a delay. I'll give you guys about 10 seconds to see. So let's say you have 2 to the 5th power times 2 to the 7th power. So who can tell me what that would equal to? And you guys have about 10 seconds. So now the way you would do this is according to the laws of exponents. So what you do, if the base are the same, if you have the same base, but you have to have the same base, if you multiply in this first number right here by this second one right here, so what you would do is keep the base. So I'm going to keep those, and then I'm going to add whatever the exponents is. So I'm going to add this guy plus this guy. So I'm going to have 5 plus 7. So I added 5 and 7. So 5 plus 7 is 12. And I keep the base, which is 2. So 2 to the 12. Now, what you don't do is multiply the 5 by the 7. You don't do that. You don't multiply them. You add them. You add 5 plus 7, and that's what gives you 12. And that's what mostly. But what made you want to do, man? Man, it's kind of like a long question. I've been doing it. It's kind of like a long question. A long answer, I would say. I've been doing it for about, Jesus Christ, I would say 15 years or something. Because I used to do it when I was in school. I used to tutor kids, and then I started doing it in college, and then eventually I don't know, I just liked it. I just liked doing it, and I kept doing it. Yeah, but it's probably like a long answer. I don't know if there's anything specifically that made me to it. It's not like I had a dream. I'm like, hey, I need to tutor math. It wasn't like that. I had a guy who was helping me a lot too, and kind of like as a reciprocity, I was helping kids in my class, and they started getting it. So eventually, I started doing it, and then I kept doing it up until now. Maybe with some breaks in between when I was doing other things, but yeah. So back to this. So 2 to the 5th and 2 to the 7th. So what you do, you add the 5 and the 7. Now, if we go, so you have, let's give you another example. 3 to the negative 4 times 3 to the 6. Now, this is basically the same example. The only thing is you have to remember we keep the base, we add the exponents when we adding. So basically, technically, what you're going to do, you're going to add these two numbers. So I'm going to add, let's do the hard part first, negative 4 plus 6. That is going to give me the exponent, negative 4 plus 6. That's going to give me what? So the signs are different. I mean, you subtract them, and then you keep the sign of the biggest one. 6 minus 4 is 2. What's the sign of the biggest one? It's the positive. So 2. So 3 to the 2nd power. And I was just going over adding numbers. So what you do, you keep the base. Base is 3 to the 2nd power. 2nd power is, how do we find 2? Negative 4 plus 6. Let me know if you guys have any questions. Yes, no, maybe. Any questions? The person who asked for exponents, do you have any questions? All right, so I think this should be good. And let me know if you guys, if you can hear me clearly too. So let me know all that. Okay. Yes, I have 5 different courses. Geometry, algebra 1, algebra 2, pre-calculus, calculus, and trigonometry. That's 6. Yeah. So I have 6 different courses that you can. It's basically what kids take in high school and middle school that you can use to get help. Um, yeah. So maybe I'll send you a link to them, and you can see the pages. So now let's move on to something else. So now you show how to multiply, a number with exponents by another number with exponents. So how do we do divisions? So let's say you have one divided by another. So let's say I have 7 to the 15 divided by 7 to the 3rd. Now, basically, what you do is you say, okay, and when we're multiplying, if we were multiplying 7 to the 15 by 7 to the 3rd, and I'll show you 2 ways to think about this. The first way is, following the law of exponents. So what we would say, we would keep the base 7, and then we would subtract the exponent. So it'd be 15 minus that 3. So the top one minus the bottom one, not the biggest one minus the smallest one. Now it doesn't always work out that way. That's the top one minus the bottom one. Same here. I'm not the best at chemistry either, Emily. Um, okay, I'm gonna go over unit circle in a little bit. I'm gonna go over it a little bit. Hopefully that helps with your quiz tomorrow. I'm gonna go over it in a little bit. So what you do is top one minus the bottom one. So 7 to the, what's 15 minus 3? 12, right? So 7 to the 12th power. Now, okay. So how do we find the 12? So we say, you take the top exponents, subtract, you take away the bottom exponents off. So it's 15 top one minus the bottom one. So now let's say you had, that's not where I want to go. Let's say you had, uh, 8 to the second power divided by 8 to the -5. So who can tell me what this would equal to? And then if I don't see any, can you explain exponential functions? Okay, we could probably go over that. Do you have a question specifically about exponential functions, like the graph? Do you have, you know, do you want to know how to graph e to the x, or how does that, what's the specific question? That would probably be helpful. Um, so who could? Do you guys have any questions? Let me go. Let me go in the chat and see if you guys have any questions. Uh, Google Classroom. Can you do SAT math? This is kind of nice. That's what's up, Alvin. That's what's up. So Alvin said he was a math tutor, and then he became an adjoint math prof. Now he's an associate prof. That's what's up. What do you teach at Alvin? So yeah, 8 minus 3. So let's see, 8 minus 3. 8 to the -3. Okay. Ken, close. That's close. So yeah, that's another way to do it. That's another way to do it. The first question, Alvin would factor the two to the third out. Yeah, that was an easier way, a faster way maybe. Let's see. All right, cool. I don't see any other questions in the chat. Let's see. So somebody answered this question, but close. So what you would do is, and I think I see where you're coming from. What you would do is 8 to the second, my 8 to the negative 8 to the second, and then minus -5. So that's very important. So you got to remember that what we're doing is the the power, the top on the top, which is right here, minus the one on the bottom, which is here. So this 5 already had a negative in front of it. That doesn't say anything about this because that's part of the formula. So you take the 2 minus whatever was on the bottom. Whatever was in the bottom was a -5. So that negative times a negative becomes a positive. So you have a 2 plus 5, and that's a 7. And I see what you were trying to do. Whoever ends here on YouTube, I think I see what you were trying to do with 2 to the -3. Kind Cane Wood. I see Woods. I see what you were trying to do. So it's actually 2 to the negative. I mean 8 to the 2 minus -5. When you say 2 minus -5, 8 to the 2 minus -5 plus 5. So that means 8 to the 7th power. And that's how you do it. Now, the other approach that we could use for this one is a theorem that I'm going to talk about it. That's kind of like the third thing that you learn when you learn about exponents. So is when you have so let's say I have a to the power of b. That's the same thing as saying 1 over a to the power of -b. So what you can do is flip-flop those. So what you do is, if you have this, if you want to invert it, you say 1, 2, the same thing, but you have to change the sign of the exponents. And that's all you do. So what's the equivalent to 1 over 8 to the 5th? What is that equivalent to? 8 to the what power? Let's see who can give me this answer in 5 seconds. That's okay. That's okay. Nice try. Who can give me this answer in 5 seconds? -5. Okay, let's see. Yeah, 8 to the -5. See? Good job, Kind Cade. I'll just call you Mr. Woods, man. So 8 to the -5. So that's how you would do this one. So now what this allows us to do is we can think about the division almost in terms of multiplication. Let's go back to this example for this one, for example. So we can think about this division kind of like a multiplication. So what we had is 2 to the 8 to the second power divided by 8 to the -5. What we had was 8 to the second power divided by 8 to the -5. The first way that we did this, we said, hey, it's going to be 8 to the 2 minus -5. That's okay. But the other way that we can think about this is 8 to the second power multiplied by 8 to the, so 1 over -5. Let me put it this way so you guys understand where this is going to come from. So what this is this is 1 over -5, and that one is 8 to the second power. I haven't changed anything because if you multiply this by this part by this part, let me change the color for a little bit. So what I have is 8 to the second power multiplied by, and I'll put the other one in blue, 8 to the -5. 8 to the second power multiplied by 1 over 8 to the -5. So now what we have here is it's the same thing. It's the same thing as 8 to the second power divided by 8 to the -5. So the only thing I did, I just split them. So the one that I was in the bottom is still there because it was 1 over that. If you multiply 8 squared by 1 over 8 to the -5, it's still going to give you 8 to the second divided by 8 to the -5. I haven't done anything magical in this. So from here, what we can say is we're going to apply the rule that we just learned earlier. This guy, if I want to invert it, I can do that by flipping the sign of the exponent. So what this is going to give me to What is this going to give me to? 8 to the what power? Who can tell me what power? Hey, thank you. Me, you. All right, Sammy. That's what's up. Yeah, who can tell me what this would be? So who can tell me what five? That's what I'm talking about, Sammy. 8 to the fifth. Yeah. So the way that works is, um, you know, if I have, if I have an exponent, I can always flip it. All I have to do is change the sign of the exponent. So I can flip it. So it was 1 over 8 to the negative 5. So I want to put the x to the negative 5 on top and then 1, and flip that. So that would give me, all I have to do is change the sign of the exponent. So that sign was negative 5. As Sammy said, that's going to be 8 to the 5th. So this thing is kind of like I have this multiplied by this now. It's the same thing, right? So I haven't changed anything. This is equivalent to this. So the blue part stays the same. So the blue part is 8 to the 5th, as Sammy said it, 8 to the 5th. And in purple, what I had is 8 squared. 8 squared. Now, what does that give you? What does that give you? I know Sammy's going to say that. What does that give you? What does that equal to? It's on YouTube. It's on YouTube. Whatever I'm writing is on YouTube. The Jax tutor. Maybe I should write a comment on here saying that. No, not a comment, but I wish I could put a note on TikTok saying that I'm not able to share the screen on TikTok, so that's why it's on YouTube. So the screen is actually a computer screen on YouTube. And if you go in there, if you click on my profile too, you click on the YouTube link, it should take you directly to the channel. You came from my YouTube channel. That's what's up. Let's see. That's what's up. Yeah, so it's on YouTube. Cool. So we're working on exponents, analysis. So who can tell me what this equal to? Let me see if I can see the comments. Yes, 8 to the 7th. That's what I'm talking about. Hey, Lizzie, what's up? So yeah, 8 to the 7th. And it wasn't too bad. It wasn't really bad. So the first thing that we learned about is, if you have a number to a certain, what exactly exponents tells you. It says, okay, if you have two numbers, a number to a certain power. So what you have to do is, take the base multiplied by its time, by itself, however many times. Now, if the exponent is negative, you can always turn it into positive using the same thing that I said. So let's say I have 8 to the negative. Let me use a different number. 12 to the negative 5. Let's say I have that. So if what this means is 12. If do you say 12 multiplied by itself 5 times? Close. So what you want is a positive exponent. So if the exponent is negative, you got to make sure it's positive first. So this is technically is 1 over 12 to the 5th, just like I told you guys earlier. So I can flip that. All I have to do is change the sign of the exponent. This is technically 1 over 12 to the 5th. So now, which is the same thing as writing 1 to the 5th. 1 to the 5th is 1. 12 to the 5th is it's the same thing as this one, which is also the same thing as writing 1 over 12 to the 5th power. That I can multiply it by itself each time. Now, that what I told you earlier and at the beginning wasn't really the whole truth, because if the exponent is negative, you got to make sure it's positive so you can multiply it by itself however many times. Questions? I think that covered most of it. Now let me do power to a certain power. So let me see if you guys have any questions first, and then I'll do a power to another power. Sorry. I think I showed you the answer on the screen. Sammy. So let's see. Let's see if I can do a power to another power. So let's say I have through 6 to the third to the fourth power. Now, so whenever you're dealing with this, is notice it's not the same as it's not the same. Let me write this in a completely different area so you don't think it's the same. So this is not 6 to the third times 6 to the fourth. This is not the same thing. Those are not the same thing. So what you do in this case is you multiply the 3 times the 4. Here, you add the 3 and the 4. And I think this confuses a lot of students because think about it. In this one, you have one base. One base. This is the base written twice. The base is written only once. And here it's written twice. They are not the same. So when you have it written this way, so all you have to do is add the 3 plus the 4. That gives you 6 to the 7. In this case, it's 6 to the 3 times 4, which is 6 to the 12th. And everything else that we said apply to those. Maybe what would be helpful is an example. If you guys have any question, let me know too, so I can go over it some more. I want to make sure that you all understand what I'm doing in this. Ooh. Okay, so let me see if you guys have any questions. Yes, no, maybe. TikTok. Okay, all right, so can we move on to the next topic? Okay, can you do geometry? Yes, I can. I'm about to do something that has to do with geometry. So, who let's see. So do you guys have any questions? Let me see first. Okay, I don't see any questions. All right, so we're gonna move on to this bad boy right here, unit circle. So this is the person who asked about unit circle. Are you still here? I know you have a quiz or a test or an exam tomorrow. Nicole, thank you for the kind words. All right, cool. So let's see the unit circle. I never understood it. All right, cool. So we're gonna go over that now. Anybody else? Questions about what we just did about exponents? All right, cool. So let's go about the unit circle. So before we go about this, let's do a little bit of review about things that we kind of know already. So if you, and this has a lot more to do with geometry than trig. So let's say we have a triangle. Let me find my nice looking triangles right here. So let's say we have this triangle right here, right? So for this triangle, let's call this A. Oh, let's call this A, B, C. And if you yes, we're gonna do unit circle now. So if you notice triangle, there's a little mnemonic that we all remember. It's called SOHCAHTOA. If you want to know the trig function for this triangle, so you use that SOHCAHTOA. Why am I writing this one? Okay, so we know. Oh, I gotta charge my. Gotta put this in the charger. Hold on, I gotta charge this computer before it dies on you guys. Let's see. 1 second. Yeah, I gotta charge this. Otherwise, y'all won't be able to see me for another few hours. So, let's see. Give me 1 second. I'm gonna plug this somewhere else. 1 second, guys. I gotta charge my computer. Otherwise, there won't be no tutoring. what's going on with my USB port? Oh no, this is not USB. Okay. All right, we're gonna go without this light. So let's like we know this little mnemonic right here, SOHCAHTOA. So you probably know exactly what this says is, sine. If you want a sine, let's say you consider an angle. Consider an angle right here. And I'm gonna go over this real quick because the um thank you. Yeah, I work out a little bit, just a little bit. So we're gonna go a little over this a little bit quickly because I'm thinking that you guys probably know this already. If you're asking about unit circle, you probably know being introduced to trigs. So let's say I consider an angle alpha here. So SOHCAHTOA, the sine is equal to opposite over hypotenuse, sine of alpha, and then this is always in relation to the angle that we consider. So the opposite side of this angle is BC. The hypotenuse is the longest side is AC. And you do the same thing for cosine. And I'm reviewing this because that's kind of like, that's probably going to be that's a little bit part of the unit circle. So the cosine say cosine is equal to adjacent over hypotenuse. The adjacent side of this angle is, the angle alpha is AB divided by the hypotenuse, which stays the same, AC. And the tangent part said, the tangent of alpha said what? The opposite side divided by the adjacent side, which is the opposite side, which is BC, divided by the adjacent side, which is AB. All right, I think these should be good. BC over AC, AB over AC, BC over AB. Now these are good. So that's what we know about trigs. Now, when we move that on to the unit circle, this is what basically that the unit circle says. So if you have those in mind, how to find sine, cosine, and tan, what the unit circle says, if I give you a circle and the unit circle, that means a circle of radius 1. And that's what it's a unit circle. It's a circle of radius 1. So let's say if I think of this as the center of the circle, let me go in black. If I think of this guy right here as the center of the circle, and I draw a line this way, and I draw a line, and these are not lines. Where's my line tool? Okay, that's fine. I'll just use this. I'll draw a line this way, right? And then if you think about this is a big circle. let me take this out and draw a smaller circle. So if I have a circle here, circle here, and when I say unit circle, it means a circle of radius 1. So if I have a circle here, let's say this point right here, I'm trying to find the center of this circle. So let's say this point right here is the center of the circle. So so there is a bunch of relation that we need to know. So the first thing that we need to see is we're going to draw a vertical axis and an horizontal axis that cuts straight in the middle of the circle. So I don't know why this is. I don't know why this is cut off on Instagram. Give me 1 second, guys. One second. I don't know what's going on Instagram. All right. It did this last time too. Give me 1 second, guys. I'm trying to figure out why is all this going on Instagram. Let's see. I'm not trying to go live again. I guess they give you, did they give you a limit to how long you can go live on Instagram? You guys let me know. All right, so back on Instagram now. So what we're doing is, we're talking about the unit circle. So let's go right here and write unit circle so people understand what we're talking about. So unit circle is, when it's a unit, it's a circle of radius 1. So now we consider the circle right here, and so think about if we draw a line, a vertical axis right here, and then a horizontal axis right here. So they cut right here in the middle, and this is the center of the circle. Consider this as the center of the circle. So I haven't done anything crazy. So let's say we take a point on the circle right here, for example. So let's go in a different color. So this is the y-axis, and this is the x-axis. Let's say, so we know we're in the first quadrant. We're going to do everything in the first quadrant. And usually when you do that, after you do that, if you want to, if you want something on the third or fourth quadrant, you just, applying the law of sines, and you'll be able to find them. So let's say you take a point right here on the x-axis on the circle. The point is, let's say we call this point, we'll call it A maybe. And this is O, the center of the circle. And this is the point A right here on the circle. How far is this point from the center of the circle? Who can tell me how far this point is from the center of the circle? And this is something that you have to understand. Who can tell me how far the point A is from the center of the circle O? So how far is this line? So how long is this line? What I'm saying is, how long is this line? Remember, we say the circle is a unit circle. How long is the blue line if the circle is a unit circle? The point A is on the line. How long is the line going from the center of the circle to the point A, which is on the circle? Let's see. Who can tell me? Okay, we probably can. Oh, you can only go live for an hour in Instagram. I didn't know that. That's kind of like something to be changed. I don't know how long I've been live, I'll be honest with you. Okay. So, yeah. Who can tell me how far is this point from the center of the circle? That's what I'm trying to see. So how far the point A is from the center of the circle? Let's see. TikTok. I might have to refresh this. It's the radius, yes. So how far it is? So if it's the radius, that means it's 1, because that's the unit circle is of, it's a circle of radius 1. So this point is the radius circle, so that means it's 1 unit. Now, here's where the magic happened in the unit circle. That's probably, you guys probably don't get. Now I'm going to draw a line from the point A onto the x-axis. And this is the line right here. Straight down. Right? So this is the line. This is the point A. So this line on purple go from the point A to the x-axis. And this one right here go from the center to the point A. So now, if we know that this is the y-axis, this is the x-axis. This is the x-axis. And this is the y-axis. Now, if I consider this angle right here, and I'm going to go in different colors so you guys don't get this messed up at all. So if I consider this angle alpha right here, alpha, and this is, this might make it, and that's why I wanted to draw a bigger circle. If I consider this angle alpha right here, nice, alpha, and I want to know what's the sine of the angle alpha. Remember, sine is, remember, go back to the definition of SOHCAHTOA. That's why we review it. Let's go back to the definition of SOHCAHTOA. Sine is, there it is right here. So if we go back to the definition of SOHCAHTOA, we see that sine was what? Sine is opposite over hypotenuse. So let's say we call this point O, we call this point A, and we call this point right here B. So who can tell me what sine of alpha is? So this is the angle alpha. Sine is the opposite side divided by the hypotenuse. And this is B right here. This is the point B. It goes from this dot A direct vertically down to and it cuts the x-axis right here at point B. So we have a point O, which is the center of the circle, with point B right here, and we have the angle alpha. Let me draw this a little bit bigger for you, so you can see how it all plays out. I'm gonna erase some of these that I probably don't need. Let me erase this. And I'll draw it on this side. I'm gonna draw the triangle, the inside triangle, so you can see how it looks like. So we have an original part that looks straight this way. Oh no, I need a line. And if you can find the answer of sine of alpha, let me know what it is. So what's sine of alpha? And that's what we're looking for. So we have an horizontal line that goes from here to here. We have the blue line that goes from here to here. And I'm drawing these so you can understand. And also we have the purple line that goes straight down. I'm making this bigger because the circle that I draw was kind of small. And we have the angle that we're considering is the angle alpha inside of this circle right here, and the angle alpha right here. Let me put the angle first. Alpha. And that's the angle that we're considering. So what is sine of alpha? And this point right here is A. This right here is B. And then this right here is O. So let me see if I can find in the comment what's sine of alpha. Thank you, Nicole. You had to memorize the degree in each quadrant. Oh wow. I'm sure that probably, I mean, that's one way to do it. That's probably an easier way. So who can tell me what sine of alpha? Come on, guys, come on. This shouldn't be that hard. I can see what you're drawing. You gotta go on YouTube to see it. What even is life? You gotta go on YouTube to see it. It's on YouTube. Is this SAT prep? It could be part of SAT. We're doing unit circle. Triangle in your second latest post. Let's see. Triangles in your second latest post. I'm not sure what you're saying. I can see the triangles. I can't see the triangle in your second latest post. You don't see the second triangle? Let me know if you're having trouble seeing it. Even my pop filter is off now. Let me know if you're having trouble seeing the triangle that I just draw. So who can tell me what sine of? I think this is showing on YouTube, right? Yeah, it is. So who can tell me what sine of alpha is? And I'll wait for the answer because you guys, whoever asked about the unit circles too. Let's see. Who can tell me what sine of alpha is? So remember, sine is opposite, the opposite side, opposite over hypotenuse. So what's the opposite side of the angle alpha? So it's the directly opposite to it. So if you go from the angle alpha out, what's the opposite side to it? You'll see. And what's the hypotenuse, which is the longest side? You'll see what it is. So, so who can tell me what the sine of alpha is? You guys who asked about the unit circle. It's the radius. What even is life? Can you tell me what the sine of alpha is? I know I see 2 or 3 of you guys asked about unit circle. Came from your YouTube channel. What's up? That's what's up. Sine of alpha. Who can tell me what it is? If not, I'll explain it to you guys until you find it. Okay, so what I basically drew here is a replica of this. So what I did is just put it in a bigger place for you guys so you can understand what sine is. Sine is opposite side, which is the opposite side of the angle alpha is AB, divided by hypotenuse. The hypotenuse is the longest side of this triangle. The longest side is the blue side. So sine of alpha is AB divided by the blue side, which is OA. Now, what are the equivalent of those on the unit circle? Now, if you're on the unit circle, right here is, so let's see, let me go dot. No. So right here, so if I draw a dot right here, this, this length right here, the length AB is the same right here too, so if I call this point A as of a coordinate XY, so we don't know what the coordinate of the point A is. X, Y, we call it XY. So that means the point A, so here's what I'm saying. And this is kind of like 2 or 3 things at the same time. So we have the x-axis and the y-axis. So we have the point A. So we had the circle. The point A is right here. So if I take away the circle and leave the point A at the same spot, there's an x coordinate for the point A. There's a y coordinate for the point A. So the y coordinate of the point A is this one, and the x coordinate of the point A is this one. And that's exactly what we're going to apply for here. So if at any point here, A of the coordinate x and y, the x coordinate is this one and the y coordinate of it is this one. Let me go and give you concrete examples. So if I'm on the Cartesian graph and I have 0, 1, 2, 3, 4, and 1, 2, so 1, 2, 3, 4. So if I have a point right here, A right here, a point A right here. So what's the coordinate of this point? This point A right here. What's the coordinate of the point A? Let me see if you guys are able to see me. So what's the coordinate of the point A right here? Guys, YouTube. My battery is going low. Oh snap! There was, okay, 4, 2. That's what's up. I was not able to see. I don't know why I'm not able to see your comments. Okay, there you go. The comments are coming a little bit later. There you go. I know you guys would answer me. That's what's up. Yeah, 4, 2. So what I'm saying here is 4, 2. That's the coordinate of there you go, Nicole. That's the coordinate of the point A. I think you're coming and lagging. Yeah, there you are. Because I wasn't able to see none of them. So that's the coordinate of the point A. So 4, 2. So what we're gonna say is 4 is the x coordinate of the point A. So somebody say 4, 2. That's exactly what the coordinate of this is. 4 is the x coordinate. So that means it's the distance from here. Let me put this in a different color so you understand what I'm saying. It's the distance from the origin to here. That's 4. That's the x-axis. So if we don't know it, we call that would be x. That's the x coordinate. And the 2, the distance from the origin up, is the y coordinate. And it's equivalent because this is a rectangle. Right here is a rectangle. This is equivalent to this. This right here is equivalent to this. This is also the y, the x and the y. So let's keep that thought and go up right here. So let's go up right here. So what we saw is, we say the sine of the angle theta, the angle alpha is AB over the hypotenuse OA, which is AB is the one that's standing up, which is also the same one that's standing up right here, which is what we say, what did we call this here? The one that's here, going from the origin up and here. What did we call this? It was 2 in this case, but we don't know it. We don't know it in this case because we're building this unit circle in general cases. We're not using numbers. So what's the equivalent to AB? What's AB gonna equal to in this case? AB, and that's what we saw here. That's what AB is. That's the length right here. Let me see what the comments are saying on YouTube. What's AB? Come on, guys. AB, no, not 2. Not in this case, not 2, because we're not dealing with 2. Not in this case, not 2, because we're not dealing with 2. So it is something else. So what's AB? Yes, Lizzie, I can do geometry. In this case, not 2, Nicole, because we are doing the general case. So we not, so remember here, the point is of the coordinate X and Y. The X is, let me write this. Let me put this in a different color so you can understand. The X is the length from here to here, just like we said on the X-axis. And the Y, I'm going to put the Y in purple, is the length from here, from the origin to the top, which is the same on both sides. And the X is the same here. And you can see it's a rectangle. So the top part here that I'm drawing right now is equal to this one. And the purple ones are also equal. So AB is equivalent to what? It's not 2, because we don't have numbers. So what is this equivalent to? When we had 2, what did we call it? What did we call it here? We say if we have, in this case, what did we call it here? What would AB be equal to, equivalent to? What did we call AB here? So if we didn't know what this point was for 2, what would this length from here to here be? AB. And it's only 2 answers, 2 possible answers. I'm at 5% on Instagram. Oh, it's about to be the end for you guys on IG. Let me see. Let's see if I can charge this one. 1 second. So let me know what's the answer is. Not 2. Not 2, guys. Come on. It's not 2. So what is it? It's not 2. It's either 2 things. It's either X or Y. So what is it? Is it X or Y? Let me see if I can find the answer on YouTube. Come on, guys. Oh, what did I do? Nope. Ooh. I almost closed up everything. Let's see. So it's not 2. It's either X or Y. Let's see. Let's see what you guys have on YouTube for me. Yes, Y. There you go, Nicole, Lil, Nicole. That's what's up. Y. Okay, yeah. So AB is Y. So AB, let's go back to the unit circle. AB is Y. So we say sine of this angle alpha that's here is AB, which is Y, divided by the hypotenuse. Remember, we are dealing with a unit circle. The first question I asked you guys, what's the length of the blue side? Remember, the blue side is the radius. We are dealing with a unit circle. A radius of, that means the radius is, so what's the length of the hypotenuse? OA. What's the length of OA? So we have the AB, which is Y. So we say sine of alpha is equal to Y divided by AB, which is OA. What's the length? The problem is on YouTube. The problem is on YouTube. Go on our YouTube channel, the Jax Tutor. If you click on my profile on TikTok, it should take you to the YouTube channel. So go on the YouTube channel. You'll see exactly what the screen is saying. So let me go on YouTube and see what you guys are saying. So yeah, 1. There you go, Sammy. That's what's up. 1. Because it's a unit circle, the radius is 1. So what we say is sine of alpha is y divided by 1. What is y divided by 1? What is y divided by 1? Y. Yeah, that's why. That's right. Yes, that's what I'm talking about. Lil, Nicole, yes. Sammy, that's what's up. Yeah, what's y divided by 1 is y. So sine of alpha is equal to y. And we're going to do the same thing for cosine of alpha. You're going to see, you almost can tell me what cosine of alpha is based on what we just did. So let's go back to the circle again, and I'm going to draw it. I'm going to redraw it like we started over, so you guys really grasp what I was saying. So we can start over. So we have the y-axis. I want to make sure that you guys can get this. You have the y-axis here, the x-axis here, and then let's say you have the circle somewhere here in the middle. Oops, this is not the best circle. The circle here. And then you had a point A of the coordinate. A of the coordinate of the point A is x and y. And this right here, nope, let me draw this. And so this one right here was what? Let's see, this one was in blue, right? This one right here was in this color, green. And then we had one that was in purple that goes from here to here. Now, what is cosine of alpha? Cosine of alpha, and I shouldn't be using this color. Maybe I should use a different color. What is cosine of alpha? Cosine of alpha is equal to the opposite, the adjacent, that's O, that's B. The adjacent side, this is the angle alpha here. The adjacent side, what's the adjacent side to the angle alpha? Adjacent is OB divided by OA. Now, we already found OA. It doesn't change. OA is in the problem. It doesn't change. It's the same problem. So we know this is 1. The reason why it's 1 is we're dealing with a unit circle. The unit circle means a circle of radius 1. OA is a point from the origin to the circle. That means it's a radius. That means it's 1 always. So what is the value of that we're looking for now is OB. Remember, OB is also the same thing right here too. So it's right here. This green part right here is right here. And if we go back into what we're doing, it's the same thing. I just redraw it for you guys to make it look cleaner. So it's that distance from here, from the origin to the point B. So which is what we use in here is the distance from the origin to the point B, which is this distance right here. Let me give it a black color, this distance, and which is also this distance. So what is the value of OB? Let me see. Let me double check the comments. X over 1. That's why. X over 1, which is X. That's what I'm talking about. Sammy, Lil. That's what's up. Yeah, X over 1, which is X. So OB is X. And that's all really there's in a unit circle. So what it's saying in the unit circle is saying that, hey, if I want the cosine of the angle here, all I have to do is, taking the x component of the point that meets so like let's say if I know the coordinate of this point right here, let's say this point right here was 2, 5, for example. The point A is 2, 5. So if I want the cosine of this angle, so what I have to do is, use this coordinate right here. But you gotta use that in radian, of course. So now what about if we have tangent? So tangent, there are two ways to calculate tangent. Tangent, you can say it's sine over cosine. So you can say that, or you could always say it's the opposite side divided by the adjacent side. So what's tangent of alpha in this case? What's tangent of alpha in this case? And that's all you kind of have to understand about unit circle, and everything else will make sense for you. All right, so what's tangent of alpha? Let me go check the comment. I know you guys are smart. You probably already answered it. Tangent of alpha? Nope. Let me see if it's on YouTube already. Tangent of alpha, y over x. That's what's up. Y over x. 1 over x. No, George, that's what's up. Lil, let me show you where it's coming from. So tangent is sine over cosine. Sine of alpha over cosine of alpha. But the other way that we say we can calculate tangent is a part of SOHCAHTOA. SOHCAHTOA is what? The other way that we can calculate tangent is what? We can say it's the opposite side divided by the adjacent side. What was the opposite side? Opposite side to the alpha is the purple one, which is what we called y. Divided by the adjacent side, which is the green one, which is what we called x. Remember, the adjacent side was x. So tan of alpha is y over x. Now, if you do use this formula, you should get the same thing. Sine over cosine. What we found for sine of alpha was y. What we found for cosine of alpha was x. That's it. And yeah, that's it. Cool. Okay. So let's see what else we got going on. All right, so somebody said, let me go over the person. Hey, do you guys have any questions? If you have any questions about what we just did. You have any questions? Let's see. Questions? Nope. Let me go on YouTube and see if you guys have any questions. Nope. No questions. All right, cool. So now, what do you guys want me to talk about first? Let's see. We have absolute value. We also have binomial theorem. So if the person about binomial theorem is still here, I'm going to show you how to use Pascal triangle to make sure that you really never have to remember those. Like never have to not remember, but never have to memorize them. And if you still hear the person who asked about binomial theorem, are you still here? If not, I think I saw a question about composite function. We can go over that. Yes, you can put your question in the chat. Depending on what it is, we can go over it. But if you have like a specific question about a problem, because I'm not able to see it, it probably will be hard for me to go over it. I appreciate it, John. John Lanko. On measuring angles. Okay, are you saying measuring with a protractor? Can you be more specific? XTRALA. Is it extra large? Extra large cheese fries. on TikTok. Can you be more specific? Okay, using a protractor. Okay, so I don't have one right now, a virtual one. I don't think I have a virtual one on the screen. This is just formulas. I don't think it has protractors in it. Yeah, this doesn't have protractor. So, but I'll show you. I'll show you something simple. I'm waiting for the person who asked about binomial expansion, so I can. Lorenzo, I'm sorry to hear that your SAT got canceled. It looks like a lot of them got canceled. ACT, both, and SAT. All right, so radian to degrees. I'll show you an easy way to do that in a little bit. All right, cool. So let me go. I kind of wanted to show that binomial expand theorem. If you're still here, let me know so I can show it. But otherwise, I think it was like a higher question, like it looks like probability or calculus and stuff. So if you're still here, I will do it for you. But if I don't see you, maybe next time you come here, I'll do it. What's the other question was? I forgot what I was about to do. What I said I was gonna help you guys with. Okay. Measuring with a protractor. So let's say you have an angle. I'm gonna give you a couple tricks. So if you have, let's say your protractor normally look like this, you know. Oh, why am I on here? So it normally is something like that, you know. So here, I could be on 90 degrees. So I'm gonna give you my best example of a protractor. Actually, can I find a protractor on Google? Give me 1 second. I'm gonna try to find a protractor on Google. 1 second, guys. Let me try to find a protractor on Google. Protractor. And now I'm trying to find how to measure for you. Is if I find an image of a protractor. This one looks good. I'll screenshot it and put it on the screen for you so you can understand what we're doing. Give me 1 second. This is taking a while. There you go. Okay. All right. I'm putting the protractor up. So what we're gonna do is I'll put it up and then I'll show you what kind of like a way to measure him. I don't have a virtual one on the software I'm using, but I'll put up the picture and show you kind of like how you would measure things if you really wanted to. I'll put him on the screen again. Give me 1 second. And I'll share the screen back with you guys. 1 second. Let me pull it up. Protractor. All right, this is what it looks like. Let's see. I'll share my screen so you guys can see it. Yeah, if you're able to hear me too, let me know. So, okay, binomial expansion. George, are you the one who asked about binomial expansion? Because I want to do it for the person, but if you're not here, it's probably if you're not here, you know, it's probably easier to just do it next time. Okay, absolute value. Okay, we'll go over absolute value a little. Composite functions, absolute value. Okay, we'll go over that. All right, so here's what a protractor looks like, and you've probably seen one before. And so the way that you do, you know, you would measure angle on these. The picture is kind of blurry. The way that you would measure angle on this, and of course you see. So what you would do is you would put one side, this side right here, and that's how I normally do it myself. And probably other people use it the other way. So you put one side of the angle on here, and then and then you put this center at the vertex, and then it should give you the measure of the angle going on this way. So this would be a 50-degree angle. So if I didn't have this, so let's say I move this guy. Oh no, this is moving the screen. Let's say I move this guy right here. So if I lay this over here and I wanted to measure this, I would just lay it this way. So, and if I have another angle again, let's say I have another angle. I'm gonna do it in blue probably. So let's say I have another angle. I'm gonna do an angle that's, so let's say this is the flat part. Nope, that's not what I want. Not use. So let's say this is the flat part, and then after that we'll go on in different parts. So in here this is saying that this is. Don't worry about this 36. It's measuring, considering the vertical angle. So let's say if I don't know what the measure of this angle is, so what I'll do is I'll take the protractor. Normally this is how I do it. Take the protractor and I just pull it into this angle. So I just pull it in here. So I just pull the protractor in here, and I put you see where the center is? This is kind of like the center of it. You put that center on the vertex of the angle, and that should give you the measure of that angle. But you make sure that this line, this bottom line, I mean, you could consider any lines. You make sure that that part is aligned with that level of the protractor. You make sure that it's aligned with that line that's on the protractor. So what I would do is making sure that this aligned with this on here, and then I would measure this. So that would be what? So what we're measuring is this angle going from this blue line. Don't worry about this line right here. Going from this blue line to here. And that's how you would measure it. So it looks like it's between 50 and 60, past 55. So so now when you measure in here, remember this is 90. Anything that's less than that is less than 90. You don't go on to 120. You say this is 60, this is 50. If you over that way, after 90 is, you would go on 120, 140, 160. So I don't know. Let me know what exactly that you're having problem with, and then I will extra large cheese fries. Let me know if that helps, and then I can give you a better example. We have absolute values. We have what else we had? Absolute values. I think my Instagram is probably gonna go. It's probably gonna go off on Instagram because this is not keeping up. All right, so let's talk a little bit about absolute value. So let's say that you have so absolute value means it's kind of like a way for you to keep things positive. So if I run something inside of an absolute value, it keeps it positive. So if I run 3, I put up an absolute value on 3, it's still 3. If I have -3, absolute value of -3 is whatever the positive thing of it is. So if I have 3, the absolute value of 3 is 3. If I have -3, the absolute value of that is 3 again. So whatever you run into the absolute value, it needs to be positive. Now the challenge comes if you're solving like equations and stuff. So let's say you have the absolute value of x is equal to 5. So if we're solving this equation, we're going to consider 2 cases because we don't know if x is a positive number, if it's a negative number. So before I go into this, so what we're doing when we have absolute value, whatever it spits out, that it's, think about the absolute value like if it's a function. So whatever it spits out, it's always going to be positive. If I put 500 in it, whatever it spits out, it's going to be the same in magnitude, but a positive. So that's what they call it, the absolute value, the distance from 0. So if I have the number line here, -5 here, 5 is here, the distance from 0. When you measure in distance, you take your ruler and say, okay, distance from this to this is 5 meters or 5 inches or 5 centimeters, however you measure in it. Distance from here to here is 5, whatever you call it. So this is like kind of like the textbook explanation of it. But the way to think about it is whatever you put inside of the absolute value, it comes out positive. So if I put a 5 inside of it, it comes out positive. If I put a negative 5 in front of it, it comes out positive. Now, when you solve in equations, that's what normally causes the most challenge. So when we solve an equation, so what we're saying is, hey, listen, I want a number here. What's the number here? X. If I take the absolute value of it, I'm going to get 5. Now, on top of our head, we could say the absolute value of 5 is 5, but also the absolute value of negative 5 is also 5. So there are two cases. So if x is positive, we have a case. If x is greater than 0, there's a case. The absolute value of x is equal to 5. That means x is equal to 5. So that means x is greater than 0. If x is negative, so the absolute value of x is negative x. So that means negative x is equal to 5. That means x is equal to negative 5. So two cases in here. So when you solve an equation, make sure that you consider two cases. The case where whatever is inside of parentheses is inside the absolute value is positive. The case where whatever is outside of the absolute value is positive. Make sense? Am I confusing you? Yes, no, maybe. All right. Yes, that helps. Okay, cheese, extra large cheese fries. So radian to degrees, composite function. And I feel so. Hey, if you guys are on Instagram, this is probably gonna go shut down. I'm at 3% on this thing that I'm using. So you might have to go all to YouTube. You guys all should be on YouTube too. That's how you're able to see the screen. So yeah, let's go on to composite functions. Let's do a little bit of composite function. I'm going to talk about binomial theorem, but the person is not here anymore. So let's talk about composite function. So let's say we have a function. So composite function is kind of like a way that I put a function inside another one. So if I have a function, let's say I have f of x is equal to, let me know if you've seen my screen. Let me see, make sure that you guys are seeing the screen. Binomial expression, just like, okay, it's nice, it's cute, so inspirational, keep it positive. Could you do something about chord in the circle, George? Okay, I don't know if we'll be able to get to that, George. I'll be honest with you, but I can keep it in mind for next time. Okay, so I'm making sure that you guys are able to see my screen. That's all. Let's see if Facebook is still alive. All right, they are. Facebook seemed like they are instantaneous too. That's cool. Wait a minute. All right. I should have taken this live to somewhere else. Okay, now, so let's see what we know about composite functions. So let's say I have a function f of x is equal to 2x plus 3, and I have another function g of x is equal to negative 5x minus plus 4, or something like that. So we have these two functions. We can, combine them in a certain way where we created a third function where, and the textbook explanation will tell you that, it'll tell you the input of what function become the output of the other function. Now, what we really need to know is that they really give you problems about is how do we composite those? How do we find f of g of x? So how do we find f of g of x? And if you try to follow the textbooks, it might be confusing if you don't really know exactly what they were talking about. I mean, if you read those multiple times, you might understand. But the way to find f of g of x, so what you would do is, hey, you guys on Instagram, please go on YouTube so you can see the screen. And this is about to die soon too. So the way you find f of g of x, so what you would do is, I have the function f. The function f of g of x means exactly f of g of x. Notice what I just did. Notice what I just did. In place of x, so that was f of x. In place of x, I replaced everything that was x by g of x. So you got to understand that when they write it, you got to understand it that way. So now I'm going to go inside of the x function. Every time I see x, I'm going to go inside of the f of x function. Every time I see x, I'm going to replace it by g of x. Does that make sense? Are you guys following? So I'm going to go inside of this function right here, f of x. Every time I see x, I'm going to replace it by g of x. G of x is this big old thing here. So I'm going to take that x out. This is going to be replaced by this. This x is going to be replaced by this. So what I had on the outside for the f function is 2 for the f of x function was, let me write that in blue and then I'll put the g of x in red inside of it. F of x was 2x3, right? 2x plus 3. So, right, that's what we had, yeah. 2x plus 3. So f of x was 2, which is equal to, so f of g of x now is 2. In place of x, there's going to be something plus 3. Now, this is where people get confused. You forget to put the plus 3. Now, remember what we're doing is the only thing that we're going to replace is the x. So I replace x by g of x. So that's the only thing that we're going to replace. We take away x, we take that away and put g of x inside of it. So inside right here in red, this is what's going to be here is the g of x. So what is g of x? And you go back. G of x is, what did I say it was? Negative 5x plus 4. G of x is negative 5x plus 4. Now, okay, does that make sense? Are you guys following? And from there, it's easy. It's just algebra. But are you following what I'm doing here? Let me make sure I check the comments. Let me make sure I check the comments. Sarah, thank you for the kind words. Let me make sure I check this comments. It's accurate. Yes, thanks. Yes. I'm not sure I'm not sure if there's a delay. I'm not sure what you guys are answering yes to. Let's see. Point Dexter. What's up? Yes. Okay, good. So you guys understand what I'm saying is. So what I did is I went inside of the x function. Every time I see f function, every time I see x, I replace it by g of x. And that's exactly what you do here. The difference between this guy right here is this whole thing right here and this. The only difference is, oh no, that's not what I meant to do. Give me 1 second. Let me go back to my page. Hold up. I think I accidentally pushed the wrong button. 1 second, y'all. Let me go back on these papers and let's see what paper I was using. I think I was using this paper. Give me 1 second. This is loading. And it was getting good too. Let's see. Was that what I was using? 17. There you go. Okay, I'll share the screen again with you guys. Share screen. I know I'm supposed to be somewhere at the bottom. Is that what y'all seeing? Let's see. Yes, that's right. Okay, good. So the difference between this guy right here and this guy right here, in place of x, I have g of x, and that's what I did. The 2 stays on its place because the 2 is not an x. The 3 stays in its place, but remember to do those. The 3 stays in its place, and then on the inside, every time I see x, I replace it by g of x. And from here, it's algebra. So I'm going to use a very different color so you don't get confused. 2 times -5 is -10x. 2 times 4 is 8 plus 3. You guys help me verify this. 2 times -5 is -10x. 2 times 4 is 8 plus the 3 that was outside right here that we never want to forget is equal to -10x plus 8 plus 3 is 11. Now, that is, as crazy as this sounds, that is completely different from g of f of x. And yeah, the screen is back on. Yes, if you go on YouTube, you'll see the screen too, live on YouTube. So that is different. The f of g of x is different from g of f of x, and I'll show you that in a little bit. So if I want g of x of x, so what I'll do is, so if I want the g of f of x, notice g of f of x. So it's kind of like the function g of x, but in place of x, what do we replace x by? Tell me what we replace x by. 12 seconds. What do we replace x by? So it's similar to the function g of x, but in place of x, we replace x by what? So let me repeat what I'm saying. So if I'm calculating g of f of x, that's going to be similar to the function g of x. In place of x, I'm going to replace x by what? Every time I see x inside of the g of x function, which was -4x, -5x plus 4, in place of x, what do I need to replace x by? What's the big thing I'm going to replace x by if I'm finding g of f of x? In place of x, what do I need to replace the x by? Come on, guys. The smart kids. Yes, that's why. That's right, Sammy. So what you're basically saying is, Sammy, that's right. So Sammy's answer is on the screen. So you can see what Sammy is basically saying is saying that, okay, I know what g is. I know what f of x is. I'm going to go inside of this function. Every time I see g, every time I see x, I'm going to replace it by f of x. So I'm going to go inside of the g function. The g function is -5x plus 4. And every time I see g, I'm going to replace that g by f of x. So by f of x. So that would be -5. Every time I see x, sorry, not g, I'm going to replace that by f of x. And f of x was 2x plus 3. Right? And then plus, remember that's what we normally forget, plus the 4, because remember that there's a 4 here. So the x is the one that I replaced by this whole thing, plus the 4. The 4 stays the 4, the -5 stays the -5. The only thing that I changed is this right here. It was x. I replace it by f of x, g of f of x. This should say g of f of x. F of x. No. Okay, this is g of x actually. This is g of x because I was trying to show you what g of x is. And then this is g of f of x. Now, you guys can do this. It's algebra, the same way that we did the other one. Yes, so I'm going to do one last thing, which is converting from radian to degrees. Instagram, this might not, you're probably not going to get this because my stuff is almost dying. Okay, so here's an easy way, and I'm going to do this probably like in 45 seconds. The easiest way that I convert from radian to degrees, from meters to centimeters, from meters to inches, from anything, any unit to another unit. This is what I do say. So I know, I just write the relation between the first unit to the other one. So I know inside of a circle, and if you don't want to remember much, inside of the circle there's 360 degrees, 360 degrees, and that corresponds to the circumference of the circle is 2 pi radian, and that's what I start with. Or if you know you can also start with 180 degrees is equal to pi radian. You can start that way, but for me, the easiest way that I can remember it is 360 degrees is corresponds to 2 pi radian. Now, from there, it's cakewalk. So let's say I want to convert 5 pi into degrees. So what I do is I put the 5 pi where the 5 pi is, right here. 5 pi, 5 pi. And then all I do is cross multiply. And that's how I do it. So that corresponds to x, so cross multiply. And I'll put x right here. That corresponds to x. So what cross multiply means? So that means I multiply this guy by this guy. And then this one doesn't have anything to multiply. And I'll multiply this one by x. You can do it that way. Let me start that way so you don't get confused. So I multiply the 360 by the 5 pi, and that's what technically cross multiply is. 360 degrees multiplied by 5 pi. That's equal to x multiplied by the 2 pi. 2 pi times x. And then I'm solving for what? I'm solving for x. I divide both sides by 2 pi. 2 pi. 2 pi, and I find x. And that's the easiest way to find it. If you understand this, let me know. Let me do another example before this goes out on Instagram, and that would be the last example. So let's say I'm converting 57 degrees into a radian. So what I start with, I know 360 degrees is corresponding. A circle, there's 360 degrees, which is also corresponds to 2 pi radian, 2 pi. And that's what I start with. And what the professor or the book asked me to convert is 57 degrees. They want that in radian. So what I do, under the column that says degrees, I put the 57 degrees in here. And then I said that's going to correspond to x. And what I do is same thing, cross multiply. Multiply by the 360 by the x. That's what cross multiply means. 360 degrees multiplied by x is equal to 57 degrees multiplied by 2 pi. And so what I did, I'm solving for what? Solving for x. I said x is equal to, divide both sides by 360 degrees. Divide this guy by 360 degrees. So that's what x is going to be. 57 times 2 pi divided by 360. And that's the easiest way for me to find it. All right, guys. I think this is it. Let me see if you have any questions. And that should do it for me. Wait, what is, oh, wait, never mind. Same answer. I remember doing it, but not sure what it is. This is converting from degrees to radian, and from radian to degrees. I'm not sure why I'm showing this answer. Yes, that's what we're doing now. That's what we were doing just now. Let me see. Any questions on YouTube? I mean, they would show up here. Let's see. I don't know why YouTube is delayed. Facebook. All right, cool. So I have about a minute left. I think. So whoever said the Facebook live only, oh, it's only an hour for the live. So I was live for like 2 hours. All right, guys, I think this should do it. Let me know if you have any questions. I will answer them. And if you don't, we'll see you guys next time. Let's see. Ooh, I'm not supposed to be disconnecting this. I got 1% left on this thing, and it's not charging. Wait a minute, y'all. All right, so I think this is it, guys, and yes, and that's it. That's all I got for y'all, and I will see you guys. I got a live again tomorrow, 30 This time is at 9:15. It's scheduled to go live. Thanks, you're welcome. Okay, you got it. Good job, Sammy. I remember doing this, but I'm not sure. Okay, you got it, Sammy. Okay, all right, cool. So I'm gonna go live again tomorrow at 9:15. So let me post this on IGTV. So free math help. So I'm gonna go live again tomorrow, and 9:15. Hope you guys can catch me. We're gonna do the same thing. So if you come on YouTube, and then we'll solve things the same way. So thank you guys for your time, and this is it for me. Thank you. Signing out. Thank you again. This was Bromel with the Jax Tutor. If you need to work with me, you can always go on the website, thejaxtutor.com. I'll write it down here for you. You can go on the website, and this should help you with class. But if it's not enough, if you go on the website, I'll be able to help you live, and one-on-one. And also we have some courses too. So if you're taking like algebra, geometry, trig, and all that stuff, we have courses that we'll be able to help you live and on them. So thank you guys, and it was nice talking to you all, and I'll see you guys tomorrow.